of oxygen. So this right here is a great question, because this is actually one of the things that you do have to memorize, because especially when you're dealing with finding the oxidation numbers of different compounds, you want to know the oxidation number of certain elements, certain atoms, because they do follow specific rules. So in this case, as it says here, so I'm actually going to read that because the answer there is fantastic. The oxidation number of oxygen is usually -2, okay? So whatever it's bonded with, typically, and I say whatever because there are a lot of different scenarios, but H2O, CaSO4, yep, and even like CO2, all of these, oxygen has an oxidation number of -2. Luckily for this situation, one of the rules as well is that hydrogen typically has an oxidation number of +1. And you'll see here that the reason why I wrote it like this is because you'll see that oxygen and hydrogen here balance out to where water is indeed a net, charge of 0. That's the goal here. So that's what you have to use these for. So oxygen is -2, there's 4 of them, that's -8. Now, SO4 by itself is SO4 2-, okay? So if it's SO4 2- and oxygen is -2 and there's -8 in total, sulfur has to be +6. And that's how we found the oxidation number for sulfur based on the oxidation number for oxygen, okay? Because that is one of the rules. Oxygen goes typically first. It's one of the first few that goes ahead, and it tells you the oxidation number for other molecules that don't have really much rules. So that's +6 there, which makes sense because calcium is also +2, considering that calcium is on the second column of the periodic table. Typically, you'll see that the oxidation number for alkali and alkaline metals are usually either going to be +1 or +2 respectively, and we can see that here. Things like carbon, sulfur, more things like in the gases area, or even not really transition metals, more so in the transition metals are good examples as well. Those things typically are, you have to find the oxidation number based on what it's surrounded by. So this carbon here, for example, O2 is 2-, that's -4. This carbon has an oxidation number of +4, okay? Now, I've said all this, but just like with everything in life, there's always exceptions. There is one time that we know so far where the oxidation number of oxygen is not -2. At least the one that typically we address and care about. And that is when it's with hydrogen peroxide. And hydrogen peroxide is known as H2O2, okay? The deluxe form of water. I'm kidding. That's not it. Don't drink it. I don't think it's even available like that. Point being is hydrogen peroxide, as you can see, just by adding in one more extra oxygen, it becomes a completely different thing from water. But here's the thing though, the reason why, and you will see in terms of everything kind of ties together with oxidation number, what oxygen is actually doing, everything. In this case, hydrogen is still going to follow this rule of +1, and there's 2 hydrogens, that's +2. So that's balance it out, we need -2, okay? And that means because there's 2 oxygens here, it has an oxidation number of -1. This oxygen in hydrogen peroxide is very different from this oxygen in like H2O, for example. Because of their oxidation number, it's working differently to share or take different amount of electrons than the oxygen in water. And that's key because, as you can see, hydrogen peroxide is quite different from water in terms of even what it does, or how it even, like, you don't water your plants to hydrogen peroxide if you ran out of water. You would pretty much kill your plants, because this isn't the same oxygen anymore that it deals with. It doesn't break down the same way. You wouldn't get H gas plus O gas as easy when you 2H2 gas plus 1O gas. You wouldn't get this as easily as you would from H2O2, because our body isn't built to break H2O2 like that, unfortunately. So yeah, that is the issue there with hydrogen peroxide. And this right here is the only exception that we know, or at least list, to where oxidation state number of oxygen isn't -2. So with that being said, this is correct. And now for question number 5.